wanted to be famous, just being real, yeah, just being how we want.
Know them all guys, they've been talking about the way I do what they heard I was good. They wanna see if it's true. They know you're the one.
Gynecological procedures such as IUD insertions and cervical biopsies are often extremely painful. Due to the nature of these procedures, local anesthetic is usually not an option, so patients are given some Tylenol and just left to deal with the pain. For procedures such as cervical biopsies where we're checking for cancer, it's important that patients aren't avoiding regular checkups because of how painful they are. Our device offers physicians a way to manage and measure the pain for patients undergoing these procedures using principles of gate control theory. The idea is that if a nerve is experiencing another unpleasant stimulus, the neural gate for pain will be closed, so you won't feel it. Our device consists of a water-cooled probe which is placed on the patient's cervix. The coolness of the probe will help block the pain of the procedure. Our device also has electrodes that will be placed on the patient's back to deliver an electrical stimulus to the nerves in the spine, which will help further block the pain. The strength of the stimuli are automatically determined by the amount of pain that the patient is in, which is measured through the patient's heart rate and a pain dial that the patient can turn. The physician can also override this automatic system and manually choose the stimulus strengths.
So the user experience starts when the device is plugged in, and then the physician can come over and open the VI, the control center, and then they will put the TENS electrodes on the patient's back in the proper position on the spine, and then the probe will go through the speculum onto the patient's cervix. The tubes and pumps will be placed in a water reservoir, and then the pain scale dial and the heart rate monitor will be given to the patient so they can control it during the procedure. Then the physician can come over and start the program.
When the device is in use, the TENS electrodes are placed on the patient's back, making contact with their skin. In addition, the water-cooled probe is placed on the patient's cervix through the speculum. Here, in our demonstration, we show the patient holding the speculum and the probe. However, in the real-life operation of this device, this physician will be holding the speculum and the probe onto the patient's cervix. Lastly, the patient will be holding the pain rating dial, which they can turn to indicate their perceived level of pain. The patient's finger is also placed on the pulse oximeter so that their heart rate can be read by the device. We can start by turning on the device by pressing the on button, which communicates with the device to start sending data to LabVIEW. We have the option to turn on the thermoelectric cooler, which turns on the light to indicate that the thermoelectric cooler is on, and the fan started going off, which is going to start cooling the water.
We can show the picture right now.
So when we started, before we started the thermoelectric cooler, the coolant temperature is being read at 24 degrees Celsius, and over time this should go down. We have the option of turning off the thermoelectric cooler and turning it back on. The level of the TEC depends on the patient's perceived pain, which they can control with this dial. Turning the dial will increase the pain rating on LabVIEW, and past a certain threshold it will display a warning that the pain is at a high level to the physician. And as we increase the pain, the level of the TEC changes. So when the pain is low, the TEC level goes down automatically, and when pain is high, TEC level goes up. And if we want to override that measurement, we can switch into manual mode by pressing the manual button, which gives access to this dial that the physician can use to adjust the TEC level to a certain amount from 1 to 5. And all of that is the same for TENS. So we can turn on TENS, which indicates to the physician through this light that it's on. We can turn it off. The level is controlled by the pain rating and by the heart rate. And we can also switch into manual mode, which gives us the option of changing it through the dial.
And then over here, you can see the TENS output with these two electrodes. And then in the oscilloscope, we're reading the signal that is coming out from our TENS circuit. So you can see we have square waves of a certain pulse width, which should be 175 right now.
Lastly, our device is able to monitor the patient's heart rate through the pulse oximeter. The heart rate is displayed on the LabVIEW front panel. Because the heart rate is high, above 100 beats per minute, the heart rate warning light is on. When the heart rate goes below or at 100 beats per minute, the heart rate warning dims. One thing we are proud of is our water cooling system. We had to conceptualize a way to deliver a cold stimulus to the patient's cervix, and we went through several ideas until we decided on water cooling. Creating a working circuit of tubes, pumps, and reservoirs was quite difficult and required some trial and error to get the water circulating and the water cooled. In addition, we had to fabricate a custom probe that water could travel through. The design and fabrication of the probe required a lot of technical as well as anatomical knowledge. Another thing we're proud of is the microcontroller code. We had to make sure everything in the microcontroller program was coordinated so that the various components did not conflict with each other and affect each individual device's operation. For example, the 10 signal had to be generated synchronously so that the correct square wave was being outputted while the rest of the microcontroller operations, such as reading sensor signals, occurred at the same time.